This conference will now be recorded.
Welcome to our sixth in a series of Vigitron educational seminars on network design, application, utilization for security applications. Today, we're going to discuss specifications, a critical component for two reasons. One is specifications determine what products you need for your application. Second, they influence which products, based on the first choice you select, are the most important for your applications and can meet the specifications of your system. Specifications are the main component in determining the success of your application. I will start by saying that no manufacturer intentionally lies or tries to mislead you. However, knowing or being able to know what standards in support of your applications or what is not stated in the specification are critical components that result in the success of your sale, installation, and applications. All of this reduces the potential for after-sales service calls, delays in payments, unhappy customers, arguments between dealers, manufacturers, and customers. So let's get started. We're going to look at specifications in terms of transmission, bandwidth, PoE transmission, environmental effects, transmission claims, and switch specifications. So let's start with bandwidth and transmission. I think we all realize that different codecs within the compression ratio require different bandwidth. So the question here really becomes, what codec is being used to determine your specification? And in this section, we're going to focus on the number of cameras that we can transmit through a specific type of bandwidth. So as here you can see in the slide that different types of coax require different bandwidths. And in relationship, when we talk about codecs such as H.264 and 265 and compare them with codecs such as MJPEG, that ratio may be as high as 6:1. When we talk about power or PoE, just as example, and we'll focus on that later on in the presentation, we talk about what are we really saying in that specification? How much power is really required in the source and how much power is really required by the camera? So in talking about bandwidth, you can see the differences in the required bandwidth between an MJPEG and an H.264. And each one of these boxes represents differences between a 3 megapixel camera and a 10 megapixel camera. So in here, what we're trying to say is not only difference in the codec, but what is the difference between the amount of megapixels within the camera that we're working with. And as you can see here, the in H.264 with an average frame rate of 42,000 bits as compared to 100,000 bits or kilobits, basically, what we're looking at here is not exactly a 10:1 ratio. When we look at it in terms of bandwidth, the total bandwidth required is 10.1 megabps when we look at the 3 megapixel camera, but goes up to 24 megabps when we look at MJPEG compared for the same type of camera when it's 10 megapixels. So taking a closer look at bandwidth, we find out that how we operate the camera also has a huge effect on the amount of bandwidth. In this slide, from what we see is focusing on a 3 megapixel camera at a continuous operation of 24 hours at 30 images a second requires a total of 10.1 megabps. But if we reduce that to 80% continuous motion, the remaining 20% being, let's say, just motion on movement itself, we find that we reduce that by almost 20%. Now, if we reduce it to just motion detection for a 12-hour basis, we reduce that by almost 60%. So how we set up the camera and what we need in terms of the number of frames recorded under what circumstances is going to have a distinct effect on bandwidth. Also, what affects it is video quality. Normally within settings of cameras, we can have different types of video quality involved in it. In this case, low, medium, and high, and we can see the differences that we have here within the bandwidth. All that equates to how many cameras can I basically transmit? Well, if you recall from our previous seminars, for those who were on it, basically, when we look at 100 megabps transmission, in reality, when we talk about packet overheads, which are required to identify the packet and transmit it, we result in a bandwidth that is approximately 50% of the total. So 100 megabps allows us to only use 50 megabps. When we talk about 1G, we basically are resulting in 500 megabps for transmission. So in this case, if we resolve that our bandwidth for a particular camera is approximately 2 megabps, we can divide that into the resulting bandwidth to determine how many cameras can be transmitted. So let's apply that. At 100 megabps, we start out with only 50 megabps for actual camera transmission. And if our camera results at 2 megabps, 25 cameras can be placed along that line. If we go to 1G, and the resulting bandwidth is 500 megabps, and again divide that by 2, we see that 250 cameras can be transmitted. The key point here is to remember all the factors involved in determining how much bandwidth is really required to achieve what you want per camera, and then apply that to only 50% of the total bandwidth of your transmission system. All of that is not generally going to be contained within the specification of a particular unit. So once again, please keep in mind the effect of those, what affects the actual transmission. Picture size, number of pictures per second, and definitely packet overheads. So let's talk about PoE, and this is perhaps even more confusing than bandwidth when we look at it. So we're looking at a camera specification. We'll start up here at the top by looking at a basic fixed camera, okay? So this is a typical camera, and look at what it says. It says that the camera requires 7 watts, but then says a maximum of 12.9 watts. What do we really mean by that, and what are those differences? Well, in previous seminars, we spoke about a surge factor. And we spoke about how that surge factor is very critical in maintaining the operation of the camera. And why is that? Because it requires more power to turn on a function than to maintain it. And within modern day IP PoE cameras, we have a lot of functions that can be turned on: day, night, LEDs, PTZs, auto back focus, etc. And if we exceed the amount of power presented at the port of a switch, let's say, that's providing PoE, we're going to get a condition that shuts down the camera, and we definitely want to avoid that. So here's a rule of thumb. In a camera specification, you could have as many as 3 different callouts as to the PoE that's required. PoE can be expressed in terms of a class, as you see here, class 3, in terms of a specific numeric power level, in terms of 7 watts, or in terms of what's called a maximum power limit, which usually reflects the maximum of the class power. In this case, class 3, the maximum class power at the camera itself is 12.95 watts. So what do we set this up for? Well, a good piece of advice is always follow the class. So the class will tell you what the source power is required and what the camera power is required. So in this case, if I was programming the port of my PoE switch, I would program it for a maximum of class 3 power at 15.4 watts in order to know that in order to provide all the power required for the camera under any circumstances would be 12.95 watts. So let's make it a little bit more confusing, especially when we talk about PTZ domes. So let's look at the power here. Here it says that we need a typical camera consumption of 11 watts, but then it says maximum 51 watts. Well, that's a big difference between 11 and 51 watts. What do we really mean by that? Well, we already took into account the camera power itself and the idea of surges. But the differential here is that this particular camera is totally powered by PoE. What do we mean by total power? Well, camera video, PTZ operation, and heater and blower. And what that means is when we want to utilize features that have a heavy power draw, such as heaters and blowers, we have to take that into account, and that's the differential. To make it even more confusing, okay, what we have here in this specification, which says that the midspan involved provides 37 watts, which is typically the maximum power that's provided at a 802.3 AT configuration, meaning class 4. But that is just for the camera itself. Or is it for the camera and the PTZ? That's not indicated by the specifications. We would assume because heaters and blowers draw so much power that it probably does not include the heater and blower, which it doesn't. So here you see again, camera consumption, typically 11 watts, maximum 25 watts. So what do I program and what do I provide the PoE for? Well, that's going to be determined by the application. If the dome is indoors and doesn't require heater and blower, I don't need to provide the camera with 51 watts. If it is outdoors, I better do it because when the camera turns on its heaters and blowers and everything else, it's going to outdraw the source and shut down the camera completely. So here again, let's look at the different levels. In one of the questions we get a lot when it comes to the specification of systems involving PoE cameras is, I need to place a PoE camera out on a pole, out on a perimeter, etc. I don't have any power there. And this is the camera that I want to use. And we do an evaluation. And what we find out is that the camera itself, and possibly the camera and the PTZ mechanism, is powered by PoE, but the heater and the blower require an AC or a DC component. Quite often we have to disappoint the caller by saying, if you don't have any power out there, either whatever is required, the AC or the DC component, you will not be able to use that camera for that application. So there are still many cameras out there that use a combination or a hybrid of power, where local power is required along with PTZ. You have to be very careful because, as the specification indicates here, it will only tell you the camera power. Further, many specifications will state the camera power with or without one of its auxiliary functions, such as in this case where it says 13 watts maximum, but 11 watts with no IR or IR disabled. Here again, it's a choice of applications. If you're not going to use the IR component, if you're not going to use the heater and blower, you only need 11 watts. If you're going to use the IR component, you will need 13 watts at the camera, okay? If you're going to use the heater and blower in this case, you need to provide an AC-DC component. In one of our previous sessions, we spoke in great detail about PoE. And we said that PoE had a great deal of variance in it, even though it might be considered as being a standard. And that's because there are different chip manufacturers that provide the PoE, called PSES, power source equipment, and different manufacturers that receive the PoE, called PD, or powered devices. When manufacturers use these different chips and put them in a circuit, they also react differently in many other ways. Including one of it being a critical area of delays in turning on the PoE. Obviously, when we put them in a network system, cabling and other factors could create further delays in them to where the units do not respond to each other. Again, that's something that's not called out within a system itself. We spoke also within the PoE environment about the variations. If I say a product is 802.3 AF, I could be defining any one of 4 different classes. So what class should I use to determine how much source power I need and how much power is required at the camera? Well, I could safely say I'm only going to go with class 3, since class 3 also involves class 0, which is the full range of the other classes. So that's going to tell me that I need a source of 15.4 watts and that the camera receiving, or the device receiving the PoE, is going to be 12.95 watts. However, I've got another variation here, and that's in the DC voltage. And we spoke a lot about the DC voltage in terms of its role, not only as a component of the total power that's reached by the camera itself, but also in terms of turning on the camera, of sort of it being a light switch that causes the PD to be recognized by the PSE and start the whole function of power flow. We'll notice that in 802.3 AF, the PSE voltage range is 44 to 57. That's a whole range. And the power received, or the voltage received by the camera, is 37 to 57 volts. That's a wide range. Do we know from the specification whether the device that we have connected needs to receive the voltage on the low side of that scale or on the high side? We don't know that. And so practicality says the only way we're going to find that out is by actually doing the installation, which sometimes it's too late to find that out when we're actually in the field. I want to point out that this also has become a factor in many, many camera manufacturers that have upgraded or changed their firmware. And actually within the same model number of a camera, you can find some cameras with older firmware that becomes operational and others that don't. Vigitron has created a device called the VI0026 in order to compensate for this, and in most cases will help correct this condition should it occur. So what to look for when we're reading PoE specifications? Well, does the specification reflect the PoE source or camera power? Again, a designation of class will usually refer to the source power. A designation of a value will usually refer to the camera power, but in most cases you might see 2 of them always refer to the class power as the maximum power of what's to be received by the camera itself. The specifications do not reflect the potential for PoE surges, which can occur on startup and most often at the start of special functions such as day-night or IR LEDs. And that difference is about 20%. Now, where that becomes critical is where, let's say we have a camera device that requires 12 watts. It's specified only as class 3, 12.95 watts. If we apply that 20%, we're actually crossing over into the area of class 4. What would I provide for a source of PoE? In that case, always go with the total plus the 20%. So what I would provide there for reliable operation wouldn't be the 15.4 watts, but would actually be the 30 watts required by class 4. We spoke about the differences in wiring, and that wiring is a key component that dictates how much power can actually be delivered to a device. Well, 802.3 AT caps out at about 36, 37 watts, and that's because of the limitation of the cabling. Cabling in CAD5, CAD5E, CAD6, CAD6 is approximately 24 gauge. In CAD6, it's about 23 gauge, but here again, for safety reasons, your maximum power still caps out at about 36, 37 watts. And that's transmitted along a single pair. When we go to 60 watts, we're actually transmitting it along 2 pairs. So 37 watts times 2 would equal 74 watts, and that's what enables us to power 60-watt cameras, provided that 60-watt camera has a dual PD system. When we go to 802.802.3 BT, it actually has 4 pairs that transmit, and 4 times 37 would be the maximum, but we always derate things. Okay, so let's talk about all of this. We talked about standards in terms of the amount of power of PoE. We know that 802.3 AF defines something, defines a certain value, and that value is a source of 15.4 watts with a delivery power over 100 meters, 328 feet of 12.95 watts. We know that 802.3 AT has a source power of 30 watts with a delivery over 100 meters, 328 feet of 25.5 watts. In reality, there are no other terms that go above that. So when somebody applies the term of PoE plus, there is no specification that relates to that, or other terminology such as PoE plus plus. There are no standards. The specification applied by the manufacturer could be anything. It even gets more confusing when we talk about 802.3 BT, because BT can generally come to mean a source of about 90 watts. But then again, it could be applied to anything over 80. So here again, it creates a confusion. So what you see under the standard line is the standard line of the standard that's applied. What you see under the name line is not necessarily a name that's applied to any standard and could be used for anything that the manufacturer deems that it wants to be. So let's talk about environmental, and this is probably one of the most misunderstood specifications. My product is hardened. Well, what does that mean? There is no specification for anything that's called hardened. In normal electronics have a temperature range of 0°C to 40°C. Translated in Fahrenheit, that's 32 degrees Fahrenheit to about 104 degrees Fahrenheit. And that's the standard you'll find for most electronic components. It has come to mean that anything above that or below that figure is hardened because it exceeds the normal operating range of electronic components. Does it have an actual meaning? Is it related to an actual specification? No. There is another terminology called NEMA TS2. NEMA TS2 is basically the temperature standards that are applied for testing under environmental conditions for traffic. For example, your overheads on your highways, your lights, etc., which have to withstand either extreme high temperatures or extreme low temperatures. And that range is minus 40°C to plus 75 degrees C. So is it a standard? Is it related to the word hardened? The answer is no. So a manufacturer, technically speaking, could apply the word hardened to anything that's below 0°C to above 40°C. The other point is, what is the claim based on? Well, what you're seeing here on your screen is the actual NEMA TS2 test. It's a very, very complicated, long duration test within a heat chamber that cycles temperatures back and forth, and the operations of the product is checked at every single point to know that it maintained operations. Well, manufacturers don't necessarily follow this. They may look at a single component and judge the term hardened by the single component that has the highest temperature range, which has nothing to do with the product itself when that component is put into the component and actually operates. So there's no standard for testing that says you must do a test in this manner in order to claim the term hardened, because once again, no standardization term for hardened. So you have to be very, very careful when you look at a product. The basic thing is to question the manufacturer. How did you determine that this product is hardened? This is my application. I have to operate within a minus 30 degree to plus 65 degree C environment. How did you test for that and make that claim? So again, be very careful. If they say they did it by assessing individual components, the product as a whole will probably not work within that temperature range. If they can give you actual testing for it, that's a sign that they can do it. So also be aware of the type of cable. Now, throughout these seminars, we've talked about cable as being the key component that determines a lot of factors for the success of your transmission. So we know what those differences are, that transmission claims are based on the type of cable, cable distance, and the performance of that cable, which is significantly different. We've also pointed out that transmission standards within the IP PoE environment are based solely on CAD cabling, solely on CAD cabling within a certain distance of 100 meters. So what does that mean? Well, what happens when a specification claims it can go out a certain distance or carry at a certain level of PoE, yet it doesn't apply to your application? And you have to be particularly cautious when we talk about IP PoE transmission in the single pair and the coax environment, because again, we've reduced the number of pairs from 2 pairs that normally handle this in CAD cabling to only a single pair. And therefore the restrictions for PoE are only 37 watts, and it becomes a strict decrease in the amount of bandwidth and bandwidth handling, especially in single pair cabling. So what happens is my product can perform on this basis. I have coax cabling in the wall, and I need it to transmit this amount of PoE over this distance, and the manufacturer's specification says it can do it. But did you read the fine print? My cabling is RG59, and they're making the claim for RG6, which means that if I want similar performance, I have to remove the RG59 and replace it with RG6, which makes no sense whatsoever. This is further complicated because while CAD cabling, if I say CAD 5, it has a certain specification of performance. CAD 5E has a certain specification, CAD 6, CAD 6A. But when I talk about coax cabling, there's a wide variety of coax cabling out there with a wide variety of different resistances. And differences in resistance are going to have a substantial effect on my ability to transmit. So what cabling do I have, and what is its actual resistance, and how will it affect my installation? When we go to single pair cabling, once again transmitting PoE and IP over a single pair, I have differences in the gauge. 24/2 or 24 gauge is basically what's used in CAD cabling, CAD 6 23 gauge. But a lot of alarm-based wiring is 18/2. So throughout the range between 24/2 and 18/2, I have substantially differences in performance on PoE and IP transmission. In general, as cable distance increases, so does cable resistance, and the amount of available voltage and power decreases. So we start with that as a general specification, and then we have to delve into the specifics of the cabling itself, and adding to that, how was the specification determined by the manufacturer? What cabling did they determine the specifications? And are there any differences involved if I don't use the cable that was used for their specifications? And here you can see the confusion involved, okay? Here's various performance charts from various different competitors of Vigitron in different areas, and you can see all the differences involved in PoE performance, and in transmission bandwidth. It can get very confusing because it's not consistent. And confusing performance that is not consistent with distance can result in a claim of performance that doesn't meet your specific application requirements. This is the difference with Vigitron. Notice the flat, easy to understand. If you want this amount of bandwidth and this amount of PoE, this is the amount of distance you can accomplish. And Vigitron only deals with specifications that is standard cabling, meaning RG59 and coax coax RG59 that emulates CAD5 specifications and performances. Remember, we talked about the resistance for the cabling being so important in the ability of transmitting. So wherever our specification cuts off is where that performance no longer applies. So the best approach is to set specifications as determined by performance and not the other way around by the cabling itself. So where the performance ends gives you a clear indication of what to expect in your product for your application. All this again leads to what we call lying truthful specifications. The claims made on the spec sheet are not lies by any means, but they may not apply to your application. When I say something can be transmitted at extenders or repeaters out 6,000 feet, I'm not lying, but the end result is 1 megabps or 1 watt of PoE, something that does not apply at all to any application that could possibly be used in a security system. Be careful of those specifications. Secondly, what is the basis of their specifications? First, the type of cabling that's going to be used, because that'll tell you whether it applies to the cabling that you have already installed or are planning to, or how the specification itself was determined by the claim that they made. Network switch specifications in their own right are very confusing. I don't know how many times we receive a phone call and sometimes it's about our equipment, sometimes it's referred to us by a manufacturer and they say it just doesn't work, the camera doesn't turn on. And we say, how much power do you have at the port? And they go, 30 watts. And we say, how do you know it's 30 watts? And they say, well, you know, the switch specification says it's 30 watts. And we say, oh, really? Okay, well, basically, what's the power level of the switch? Do they give you a specification for total power and PoE budget? No, there's only one specification. Well, did you know that if you run your power level at that full amount, it's not possible because the switch itself needs some power? So if your switch says 400 watts, okay, there's no way you're allocating 400 watts solely to PoE. Second of all, if you did that and you ran your switch to total power, you'd be creating a mini convection oven, which could substantially damage or at the very least lower the operating duration of the switch itself. So we're going to take 25% of that off to create a buffer between your total power and your PoE budget. And then we're going to divide it by the number of ports. So the end result is this example here, which the power level is somewhat dated, but it proves the point. In this case, we might think that every port operating at the same time is 15.4 watts. But as we drill down in the specifications, we find out that if we're using every single port for PoE, which is typical in many of our applications, we're only at class 2 at 6.49 watts. That's a very, very big difference. The other thing that's unspecified in network switches is how PoE is required. Some network switches do it on the basis of automatic port priority, which means that port number 1 gets the most power. But as we connect cameras through different ports, starting with port number 1, we reduce the overall amount of power that's available for PoE. And eventually we get to a point where we plug in the 6th, 7th, 8th camera, and there is no more power left. It's sort of like overdrawing your account at the bank. At some point, you're going to run out of money. Other switches share power automatically. So every time we plug in a camera, we reduce the amount of overall power that's available because we keep dividing the amount of power. This reduces the power at every single port. So even though we have a connection to port number 1, we may start out at 15.4 watts or 30 watts, but by the time we plug in our 6th or 7th camera, it's been divided down so much that all the cameras go offline. A third methodology is where you, the user, are allowed to program in the amount of power to each port and the priority of each port. But there are no standards, and there's nothing within the specification of a switch that will tell you how to operate it that way. So you don't know. So you think when you plug in the 6th or the 7th camera and your whole system goes down, you think either the switch or the camera is defective, or when the 6th or 7th camera doesn't light up, you think the camera itself is defective. And it's not. You just haven't read the specification because the specification hasn't told you the operation of how PoE is applied. So once again, a little word of thumb is when you're dealing with network switches, take the total amount of power times that by 0.75. Then take the number of ports that operate PoE and divide it into the number, and you will get the maximum amount of power that's available per port. What about jumbo frames? We spoke about jumbo frames when we spoke about network switches, and we spoke about the fact that when we're connected from the port of a switch at 100 megabps into a camera itself, the total operation is 100 megabps. And almost all standard data switches at that point will limit the packet size to 15, 18 bytes. But wait a minute, the specification of the switch itself says it handles jumbo frames, and it does. But it handles jumbo frames only in the 1G mode. And I cannot program the port of a switch at 1G if my incoming is 100 megabps, or certainly if they're communicating by auto speed check, it'll go to 100 megabps because I will drop frames. So my communication out from my port of the camera into the port of the switch must remain synchronous. So therefore, I'm limited to 15, 18 bytes. Okay, and what are the conditions there? Well, pixelization. The problems become greater and greater and greater as the amount of megapixels grows within a camera itself. Also lacking in the specifications might be the switch fabric or the bandwidth of the switch fabric. And as we stated there, it must be 2 times the sum of the highest bandwidth of all the ports. So you can see that the amount of information that's left out of a product specification is as important as the amount of information that's put in the specification itself. And this is why Vigitron has a design center team staffed with real engineers that can help you create a bill of materials specifically for your application. For over 9 years, Vigitron has worked with major manufacturers to conduct interoperational testing of their product in the areas of cameras, access control, LED lighting, and wireless. And why do we do it? We're not testing the performance of the product itself. What we're doing is we're testing to see how it operates within a network and to create products that will specifically bring out the best performance between the connected devices. We provide this service free of charge and without any obligation. And because of all the unique characteristics of designing a network, it cannot be done by a drop-down menu or a computer program. It is done by real engineers that will work with you. Again, free of charge and without any obligation. Why can we do it? Because Vigitron is the only manufacturer that provides almost 250 products covering every single category of networking. And therefore, we can put together total systems that are IEEE compatible to either provide total network solution or integrate into existing networks. And it avoids another very important factor, and that's finger pointing. When you buy products from different manufacturers and they don't work, you always get into the idea of calling them up and one blames another, nothing gets done, you've wasted time, You're not getting paid. Your customers do not have operational systems. It's frustration. And we avoid that by being able to provide every single product within every single category. More importantly, too, every one of these categories that you see up on your screen is backed by multiple products. So many times we can offer 2 or 3 different configurations for your network, always on the side of reliability. Our products are designed, tested, and quality controlled in the United States with local design and support engineers from skilled engineers, which continue to support you even when you're out on your location doing your installation. And all of that is wrapped up in the industry's longest warranty of production lifetime plus 3 years, which means even when a product goes out of production, you're totally protected for a 3-year period. We thank you again for taking the time to view this seminar. And for more information, answers to any questions, Design Center support, please email us at support@vigitron.com. You have our contact information there, and you can contact myself, Neil Heller. You see my email address, as well as my phone number there. Thank you again. We look forward to you viewing other presentations.